happy to see all of you watching our videos on Diophantine equations, an aspect of numbers theory. And in today's case, we want to solve this problem. Find the values of x and y in 1027x plus 712y is equals to 1. Now, to solve this question very well, even though I started solving it on the board, we need to understand what a Diophantine equation is. We need also to understand how we apply Euclid's division algorithm in solving up to this level and finding the GCD, that's the SCF of these two large numbers. And then the aspects of the solution that Bezout's theorem comes into play. But before you go into that detail, I need you all to subscribe to that channel, to watch the video from the beginning to the end, as well as share this video so that many other persons can learn from it. Now let's look at the board again. What is a Diophantine equation? Today's case, we want to look at linear Diophantine equation. An equation is said to be linear if the highest power of the variable is 1. In this case, because there is nothing written on top of x and y, means that the power of x is 1, that of y is 1. That makes it a linear equation. But when we say an equation is a Diophantine equation, a linear Diophantine equation is the equation of the form ax plus by is equal to c, where a, b, c are all integers. So now let's dive into the question and begin to see how do we apply Euclid's division algorithm. The method of application is this way. We take the two numbers given to find their HCF, write out the bigger number and divide it by the smaller number and write out the quotients and the remainder. Like in this case, if we divide 1027 by 712, the quotient is 1 and the remainder is 315. Now, if you observe that between 712 and 315, the bigger number is 712. So you have 712 divided by 315 will give us 2 as the quotient and the remainder of 82. In the case of the next line, if you take 315 and 82, and then divide 315 by 82, the quotient is 3, remainder 69. Then we take 82 and 69. Divide 82 by 69, our quotient is 1, remainder 13. If we divide 69 by 13, our answer is 5, remainder 5. If we divide 13 by 4, the quotient is 3, remainder 1. And that simply tells us that the last number here as a remainder is the GCD or HCF of these two large numbers. That is 1027 and 712. That is how we can apply Euclid's division algorithm, because we keep on dividing the bigger numbers by the smaller numbers in order to have the remainders. You can see these ones in bracket are called quotients, and then these are the numbers we divided the bigger numbers from. So at this point, these are the dividends, the divisors, the quotient, and the remainders. Let's go into Bezout's theorem. Bezout's theorem actually makes it easy. I'm not going to the statement of the theorem, but the easier way is we can begin down from the last value of this Euclid's division algorithm problem and then walk back to the question given to us. Now let's see how that can be done on the other side of the board. So if you expect the fact that 13 minus 4 times 12, the answer will be 1. So we can use the additive inverse of 4 times 12 to have that 1 will be equals to 13 minus 4 times 3. And that is called that equation 1. Now, in the second line, if you want to make 4 the subject, 4 will be equal to 69 minus 13 times 5. Let's call that equation 2. Now, in the third line, to make 13 the subject, 13 will be equals to 82 minus 69 times 1. Let's call that equation 3. Then in step 4, from down, we can make 69 the subject. To have a 69 is equals to 315 minus 82 times 3. Let's call that equation 4. In the fifth line, let's make 82 the subject. To have that 82 is equal to 712 minus 315 times 2. Let's call that equation 5. Then the last line, we make 315 the subject. That means 315 is equals to 1027 minus 712 times 1. Let's call that equation 6. So with this, we can now substitute the second equation for the numbers that it actually applies. Let's take, for instance, equation 1 is 1 is equals to 13 minus 4 times 3. Now, in equation 2, 4 is equal to 69 minus 13 times 5. So we can now take 69 minus 13 times 5 and plug it in place of 4 here. So that we can have 69 minus 13 times 5. Now, this 3 here can remain where it was because everything here is 4. So that we can expand this to have 13 minus 69 times 3 by opening that bracket. Then minus times minus is plus. We have 13, 5 times 3 is 15. Okay, at this point, there is just one 13 here, while there is 15 13 this side. So you can say 1 plus 15 is 16. So you can have 13 times 16 minus 69 times 3. Okay, so we are done with that part. Now let's go back up to equation 3, where we have that 13 is equal to 82 minus 59. So where we have 13 here, we can put 82 minus 69. Then this 16 that is here remains where it was. Then we keep on writing this minus 69 times 3. Okay? Now let's find this bracket to have that 82 times 16 minus 69 times 16 minus what we have here, that's 69 times 3. Now, on the board, you can observe that 69 is a variable. That is how we see it as a variable. Now, let's look at 16 and 3 as coefficients. So we have minus 16 of 69 minus 3 of 69. That will give us minus 19 of 69. So we have 82 times 16 minus 69 times 19. Okay, now let's go to equation 4, where 69 is equal to 315 minus 82 times 3. So you can now plug this in place of 69 in the last equation. So that 1 will be equal to 82 times 16 minus, where we're supposed to have 69, we write 315 minus 82 times 3. And then we come back to the board, but we have 19 here. So we write the 19 because everything here is 69. So that we expand this bracket to have 82 times 16 minus 315 times 19 minus times minus is plus 3 times 19 is 57. So we have 82 times 57. Okay, because we have 82 here and 82 here as variables, their coefficients are 16 and 57. Because of the plus sign, we are going to add 82, that is 57, 82, and by 16, 82. So 16 plus 57 will give us 73. So that we have 1 is equals to 82 of 73, then minus 305 times 19. Okay, that takes us to equation 5, where 82 is equal to 712 minus 315 times 2. So you're going to plug this in place of 82 here, so that we have 1 is equals to, where you're supposed to have 82, we have 712 minus 315 of 2. Now, the 73 here will follow. So we have 73 minus 315 times 19. Okay, so we are going to expand this bracket to have 73 times 712 to have 712 times 73. Okay, then minus 315. 2 times 73 is 146. Okay, then minus 315 times 19. Now, the variable is negative 315. So you need to add 146 to 19. That should give us 165. So that we have 1 is equal to 712, then times 73, then minus minus that will be 315 of 165. Then you go to the last line where 315 is equal to 1027 minus 712. So when we have 315 here, we are going to plug in these values so that we have 1 is equal to 7112 times 73 minus, where we have 315, we write 1027 minus 712. That takes the place of 315, then times 165 that is outside. So we expand that part, we have 1 is equal to 712 times 73, then minus 1027 times 165, minus is plus 712 times 165. Okay, so 165 here have a coefficient, so 712 here have a coefficient of 73, and 712 here have a coefficient of 165. So you're going to add 165 to 73. That will give us 712 times 238. Then minus 1027 times 165. Now we can write this to say that 1 is equals to 712 times 238 plus 1027 times negative 165. So from here, you can declare that our x from the question we were given, you can look at the question again, 1027x plus 712y is equal to 1. So x will be equal to negative 165 and y is equal to 238. Now we can check these numbers by plugging in negative 165 for x and then 238 for y, and verify that your answer is going to give us 1. Let's try that out. Let's write our check here to see that 1027 times negative 165 then plus 712 times 238. If you simplify this, you are going to have 1, which means that our solution is actually correct. I want to appreciate you for your patience. And if there's any aspect you don't understand, please write comments in the comment section. And also watch many times in order to get used to it. You can check online for more questions on linear Diophantine equations. Use it and solve to get used to it. And then invite more persons to watch by sharing the video and subscribing to this video. Thank you so much.